For f composed with g, this is f of g of x. So our inside function, g of x, we'll go ahead and write that out first. G of x is x plus 2. X plus 2. Now, we are doing f of x plus 2. And so this here is our input for x. Every time we put an x into our function, we're going to actually put an x plus 2. All right. So this then is the square root of, and now that's our input, x plus 2 squared minus 1. Okay. And we could go ahead and multiply this out if we'd like. I'm not going to worry about that because it's not super interesting. And it'll, when we go to our domain, it'll help us to leave it in this form actually. For g composed with f, that's g of f of x. So we'll start with this inside function, f of x. That's g of the square root of x squared minus 1. And now we go ahead and plug that into our function g, and so this as our input, that goes into that x, okay, right there. And so we then have, well, just that square root of x squared minus 1, and then plus 2. Okay, now for our domains, we'll start with f. Okay. Well, f, we have a square root of x squared minus 1. So when you have the square root of something, that thing has to be greater than or equal to 0. Okay. If we add 1 to both sides, that gives us x squared has to be greater than or equal to 1. Well, now if we want to take the square root, this is where we need to remember some strange rules with the absolute value sign. If you want to take the square root of this, it splits it into 2 different possibilities. Okay, if you do the square root and leave it as a positive, you have x greater than or equal to the positive 1. You just keep the sign the way it is. But if you flip and use the negative, then you flip the sign. So x is less than or equal to negative 1. So this gives us 2 possibilities here. So our domain of f is from negative infinity up to negative 1. That's this thing right here. And then union from 1 up to infinity. Notice the brackets because negative 1 and 1 are included in our domain. All right, then for g, well, our function g, if you look at that there's nothing happening here that could stop us from evaluating this function. There's no division, no square roots, so there are no restrictions here. So our domain for g is all real numbers. Now for f composed with g, let's go ahead and look at this function here. We know that, of course, the domain of g is all real numbers, so we don't have to worry about that. Now we just need to worry about what happens when we apply f to that, and that's this function here. And now the square root, we've got the square root of the x plus 2 squared minus 1. And so that thing that we're doing the square root of has to be greater than or equal to 0. Okay, so now if I add 1 to both sides, I get x plus 2 squared is greater than or equal to 1. Now when I do the square root, it's going to do the same thing as what happened up here. Okay, we get 2 different things. We get either x plus 2 is greater than or equal to the positive square root of 1, which is 1. Or if we want to flip the sign and use the negative 1, then it flips the inequality as well. So x plus 2 less than or equal to negative 1. Now if we subtract 2 here, we get x greater than or equal to negative 1, and here x less than or equal to negative 3. So the domain for f composed with g then would be from negative infinity up to negative 3 inclusive. That's from this inequality here. Union, and then from negative 1 inclusive to infinity. And finally, for g composed with f, well, f already has a domain, a restricted domain of this thing right here, negative infinity to 1, negative 1, union 1 to infinity. But after we've plugged something into f, and then we want to plug it into g, g has a domain of all real numbers, and so we don't need to worry about any restrictions there, and so it's just the domain of f. And so we've got our negative infinity to negative 1, union 1 to infinity.